Hello everyone, my name is Miguel. I'm the computer engineer for the Group 9 Senior Design Project for the Thermal Dune Energy Storage Battery.
And I'm Tanner Sear. I'm one of the electrical engineering students.
My name is Felipe Pestana Francis. I'm one of the computer engineering students.
My name is Michael Hernandez, and I'm the electrical engineering student.
Hello everyone, my name is Miguel Baca. I'm one of the computer engineers for Group 9 doing the Thermal Dune Energy Storage Project, or as we like to call it, the SAN battery for short. You're actually looking at the project here as well. The idea was to kind of model it after a coffee table. The inspiration for this project was some research that we had found which said that over 50% of electricity used up north is actually used for home heating. And that's not accounting for natural gas or oil heating on houses as well. The thought process for this project was that we would probably be able to help people save money on their electric bill by allowing them to store a sort of battery or to charge a sort of battery during off-peak electric rates and then use that energy to heat their home during peak electric rates, like during the day, when they're most likely to need that heat. The main comparison for this project that we had was lithium-ion storage. Raw lithium cells will run you about $200 to $300 a kilowatt hour of energy, and that's just the raw lithium cells. That's not including inverters and installation, no licensing or permitting costs. Our goal was to beat $300 per kilowatt hour of energy storage. And so our approach was, if you want to make a dirt cheap battery, why not make it out of dirt, or sand in this case? So the Thermal Dune Energy Storage Battery utilizes a sand core, is what we call it. And I could come up here and kind of give you a little glimpse into what that looks like. And the idea is that the battery will allow you to start heating up this sand through the off-peak hours that you can schedule yourself. And as soon as it reaches its full charge capacity, it will turn itself off. And then it can start heating the room during your designated scheduled heating hours. One of the ways you can interface with this battery is with our little custom LCD here on the side. So this LCD gives you just about all the functionality that you'll need. You have your current time, external temperature, as well as your internal battery temperature. So this battery, you can also tap it and it'll give you a rough percentage of what the calculated internal percentage charge would be. You can also go into settings page, and in the settings page, you can set your desired schedule that will start for charging, heating, as well as your ambient temperature. You can select the start time, for example, for charging, tap and hold on the up button, and then it'll start incrementing by 15 minutes at a time. At that moment, when it is 4:15 in the morning, the battery will start charging. And then I guess at midnight, it'll turn off. If I press save, the ESP32 will actually take that information and upload it to a cloud-hosted database, which we'll get to later, but this does tie in with the mobile application. There are two main interactions that you can do on the main screen. That is overriding the schedule functions. So first off, we have charging. If you tap charging, the little yellow light turns on, and if we look over here, forgive me, it's upside down, you'll see that the battery starts pulling about 991 watts. If we come back to the screen over here, we have a little yellow indicator that will tell you that the battery is charging. With that, you will see the internal temperature obviously start to increase. If I turn this off, we can go back to the kilowatt measuring thing here, and we will see that we are pulling our passive 2.1 watts. 2.1 watts is used to power the ESP32 as well as any of the other relay components that are inside. Now there's the second override function for our scheduling, and that one's going to be the start heating button. This one right here, fair warning, it's going to be loud. When you turn it on, you have an inline HVAC fan that will turn on, as well as an inline dampener valve. That dampener valve takes roughly 15 seconds to fully actuate. And once that does, come over to the far side over here, that air is pushed through copper tubes that run through the superheated sand inside of this thermal sand battery. And then on this side, you'll start feeling nice, warm air, maybe hot air sometimes, start heating up your room. Now if we come back to the other side, if we want to turn it off, we just press the same button. And that turns it off. One fair warning though, because the dampener has to go through a full actuation cycle, sometimes it'll power the open and closed terminals at the same time, which is why the fan runs while it's closing. This is also useful because it prevents heat from backfeeding towards the sensitive electronic components, as well as the dampeners and the fans. So it's kind of a built-in safety feature that we have there as well. Now, I did tell you guys about an app that we had. So the ESP32 and the app both can connect to each other through a cloud-hosted web server. As you can see, the Mongo database is not receiving any updates. We were running a few tests, but how would you connect it to the internet? So the way that ESP32 works is that if it doesn't connect to the internet, it creates a local access point called TDS configuration. The access point will get the 10 strongest Wi-Fi networks that are nearby and then present it to you as an option to connect to. As you can see, it shows the strongest option was Michael's iPhone, but if I tap that, I have plenty of other options that I can connect to. So we're gonna stick with Michael's iPhone. We know his password is 1, 2, 3, 4, 5, 6, 7, 8 for that local connection. And if you look down here, the ESP32 will restart. And then when it tries to reconnect to the internet using the new preferences, you'll have a little Wi-Fi symbol that pops up there. Now, if you look up here in the web server, the ESP32 starts sending battery updates to the web server. In this case, it'll say what the desired ambient temperature is, what the scheduled charging and heating hours are, and as well as in the app, it gives you the opportunity to toggle the heating and charging from your phone. So this updates every 15 seconds. In our testing, because of internet delays, it can take between 15 to 20 seconds, which we can put up on the screen for you. And here's the app as well. So within the app, we have a nice little login page. I've already made an account for this. So I'll do Miguel ESA Solar and we'll do MAPU 1, 2, 3, 4 is my password. And then I press login. Oh, this isn't connected to the internet. Let's connect here. I'll just connect to Michael's iPhone as well. There we go, connect. Now I go here, log in. Login successful. So here we see the landing page with all of the current information that is set within the ESP32. We have the room temperature, desired ambient temperature, as well as the charging schedules. If you don't have a battery that is associated with your account, you can click on add battery and you can give it a nickname and type in the battery ID that would come in the instructions ideally for you. So for example, my nickname is Miguel's Living Room. Within your profile settings, you can also come in and set your desired charging and heating times in hours and minutes. And then, like I said before, here's the toggle charging and toggle heating. So for example, if I toggle heating, the app will send a post request to the server, raising a scheduling flag that the ESP32, after 15 seconds of looping, will read and start heating your room. Do the same thing, turn it off, and then after about 15 seconds, the ESP32 will reread the information from the web server, see that heating flag is set to true, and then recognize that we want to toggle the heating and cooling, not just the heating functionality of the battery. So that's our app, and this still goes through its full actuation cycle.
I know my peak hours are past 8, so I want to start charging after 8:30. Military time, because I'm still in the military, so. Takes a while. 2000. 2000 military time, 2015. And I know that I wake up at 6 a.m. and I'd like to have my battery charged by then. Even though I live in Florida, I know that I want my room to heat up when I get home. And I get home at 3 p.m. So that would be 1500 military time. And I want to stop charging before I just like to heat up my room for about an hour. That's fine. Let's save that. And I want my room temperature to be 30 degrees Celsius.